In the modern world, computers are incredibly important to our daily lives. They grow more and more powerful with each passing year, and they are able to compute problems that would otherwise be nearly impossible to solve. But what would the simplest possible machine that could still solve such complex problems look like? In 1926, Alan Turing, an English mathematician and one of the most important figures in the history of computer science, came up with an idea for just such a machine. Despite its simplicity, given sufficient computing time, his machine was able to run any calculation imaginable. Later known as a Turing machine, it consists of two parts, a long tape divided into many cells, each either inscribed with a symbol or left blank, and a head that could read the tape and modify it. The head was able to move the tape from left to right to change which cell it's reading, change what symbol's on the cell, erase a symbol to create an empty cell, and write a new symbol if there wasn't one. First, the machine is fed a tape as an input. The head then checked which state the machine was in, meaning which cell it was reading and what symbol was written on it. By following a set of internal instructions, the head moves up and down the tape, modifying cells if necessary. The machine goes from a starting state until it reaches a halting state, meaning it finished computing, and the new state of the tape would be its output. Because the tape can be any length, the machine could solve any problem, given enough time. However, it is possible for the machine to get stuck in an infinite loop, and thus never reach a halting state. Turing determined that it would be impossible for a Turing machine to figure out beforehand whether or not it would be unable to halt. In doing so, he solved the decision problem in mathematics, finding that it is impossible to know whether all mathematical statements are provable. Because Turing machines are so simple, they've been recreated inside many other systems. Any system that is capable of performing all the functions of a Turing machine is known as Turing complete and can theoretically perform any calculation. Over the years, everything from Minecraft to Magic the Gathering have been shown to be Turing complete, and today, I add to that list Pokémon. Despite the fact that they keep making bad games, Pokémon is one of my favorite video game franchises of all time, and, given the sheer number of Pokémon and their many abilities, items, and moves to choose from, its battling system is surprisingly complex. I have designed two teams of Pokémon that, by battling, can simulate a Turing machine. Several people have done some version of this before, but to my knowledge, this is the first Pokémon Turing machine that is both operated by playing the game as opposed to just using its code, and actually usable without modifying the game in any way. To use this Turing machine, you'll need one copy of Pokémon Scarlet or Violet, two of any model of the Nintendo Switch, and a lot of time. I'll try to explain a bit of the Pokémon mechanics involved, but the machine is complex enough that you would probably want to know a bit about the games already. Although, given that you clicked on this video, you probably do already. But to start, a Pokémon's ability is a passive effect that it has, such as an immunity to some form of damage, or the capacity to alter the stats of other Pokémon in the battle. A Pokémon's moves are the attacks it can perform on its turn. This team is created for a double battle, meaning each side uses two Pokémon at a time. To show how it works, I'll be using Pokémon Showdown, a fan-made battle simulator that's much easier to make a team in than the official game. The first team consists of only two Pokémon, a Smeargle holding a Leppa berry that has the ability Own Tempo and the moves Recycle, Glare, and Peck, and a Persian also holding a Leppa berry that has the ability Limber and the moves Agility and Switcheroo. The second team has another Smeargle also holding a Leppa berry and with the ability Own Tempo, but the moves Recycle, Heal Pulse, and Doodle. All five other Pokémon on this team are Porygon, each holding a Leppa berry, the ability Analytic, and the move Recycle. The Porygon's role could be filled by many other Pokémon, but Porygon fits thematically as it is canonically made out of computer code. In addition to being a nightmare to play against in competitive, Smeargle is the only Pokémon that can learn every move. Out of the four Pokémon that will be out on the field at the same time, both Smeargles and Persian together are the head of the Turing machine, and will always be out, whereas the Porygons represent the cells of the tape, and will switch between themselves. Each Porygon is nicknamed a number between -2 and 2, to denote which cell they are. To be Turing complete, my machine will have to be able to perform all of the functions of a Turing machine that I mentioned before. To start the battle, player 1 sends out Smeargle and Persian, and player 2 sends out Smeargle and Porygon 0. This is the start state of the machine. Now, let's see how each function works. First, we need to be able to move the tape left and right. This is pretty simple. To move the tape to the next cell, player 2 switches out Porygon 0 to the next numbered one. However, there is still a problem. Since all the other Pokémon stay on the field, their actions could still affect other Pokémon, and this might mess something up later. To solve this, every Pokémon has a move that does not affect the other Pokémon on the field in any way. However, there is a second, more complicated problem. Pokémon's moves can only be used a certain number of times in a battle, defined by their PP, or power points. Once a move's PP are used up, that move cannot be used for the rest of the battle. Once all the PP of all the moves a Pokémon knows are used up, that Pokémon struggles instead of attacking, cutting its own HP. To get around this, each Smeargle is holding a Leppa berry, as I mentioned earlier. If one of Smeargle's moves are out of PP, consuming its Leppa berry will restore 10 PP to that move. Also, the Smeargles know the move Recycle, which restores their held item if lost. This means that the Smeargle can both periodically replenish the PP of their moves, as well as replace the Leppa berries that do this, allowing them to continue playing indefinitely. If a Pokémon uses Recycle while it still has an item, such as a Leppa berry, the move will fail, meaning that the Pokémon doesn't use the move and effectively passes its turn. As I said earlier, the Porygon know Recycle and have Leppa berries as well. Persian can't learn Recycle, but it can restore its Leppa berry in another way, the move Switcheroo. Switcheroo allows the user to switch items with the target, even if one of the two Pokémon has no item. This means that once Persian's Leppa berry is used up, it can steal Smeargle 1's berry, which Smeargle 1 can replace with Recycle. So every Pokémon can play indefinitely, meaning that the battle can continue forever without any Pokémon ever running out of PP. So, here's what a full movement of the tape by one cell would look like. First, Porygon switches out. Then, Persian uses Agility. Next, both Smeargles use Recycle, which fail, as they both still have their Leppa berries. Next, I'll explain how to write a symbol. Instead of 1s and 0s, the Porygon are either paralyzed or not paralyzed. Paralysis is a status condition, which is an effect applied to a Pokémon that can do several different things. Paralysis causes the afflicted Pokémon to move slower and to have a chance to fail its move. The reason I chose paralysis is that it's the only status condition that is permanent unless forcibly removed, does no damage to the Pokémon afflicted with it, and that does not prevent the Pokémon from continuing to battle. To paralyze the Porygons, Smeargle 1 knows the move Glare. At the start of the battle, player 2 switches between their Porygons so that Smeargle 1 can use Glare on the ones that should be paralyzed. This feeds the input of the Turing machine by writing down the symbols of the tape in the correct places for the starting state of the machine. Here's how writing a 1 looks. First, Persian uses Agility. Then, Smeargle 2 fails using Recycle. Next, Smeargle 1 uses Glare, paralyzing Porygon. Finally, Porygon fails using Recycle. To write a 0 in a cell, a Porygon must be cured of its paralysis. Unfortunately, all the possible status condition curing moves that Smeargle can learn either only affect the user or all the Pokémon on the user's team. Persian is on Team 1 specifically to get around this. Persian has the ability Limber, which makes it immune to being paralyzed. In addition, if a Pokémon gains Limber after they have already been paralyzed, they are cured of their paralysis. To pass this ability along, Smeargle 2 has the move Doodle. Doodle replaces the user's and its partner's, in this case a Porygon, abilities with the target's ability. Here's how writing a 0 looks. First, Persian uses Agility. Smeargle 2 uses Doodle on Persian, curing Porygon's paralysis. Smeargle 1 fails using Recycle. Finally, Porygon also fails using Recycle. But wait, you might be wondering, what if a Smeargle gets Limber and needs to be paralyzed later on? It's immune. Simple. First, Persian uses Agility. Smeargle 2 uses Doodle on Smeargle 1, giving Porygon own tempo. Smeargle paralyzes Porygon with Glare. Porygon fails using Recycle. Now, the Porygon's ability is Own Tempo, which has no effect on whether or not a Pokémon can be paralyzed. Finally, here's how to erase a cell and rewrite it. I decided that to represent a cell being erased, a Pokémon would take damage. A damaged Porygon is equivalent to an empty cell, and a Porygon at full HP is a cell with a symbol. So, Smeargle 1 knows the move Peck to damage the Porygon. First, Persian uses Agility. Smeargle 2 fails using Recycle. Smeargle 1 uses Peck on Porygon. Porygon fails using Recycle. To unerase a cell, Smeargle 2 heals Porygon back to full HP by hitting it with a Heal Pulse. First, Persian uses Agility. Smeargle 2 heals Porygon with Heal Pulse. Smeargle 1 uses Glare on Porygon. Porygon fails using Recycle. If the new number is 0 instead of 1, Smeargle 1 would fail using Recycle instead of Glaring Porygon, leaving it unparalyzed. So that's it! The Pokemon Turing Machine is Turing complete! It can move the tape and write and erase symbols. By following a set of instructions and creating an input by paralyzing certain Porygon, you can use these teams to calculate anything imaginable given enough time. Except, there's one problem. A Turing machine's tape might need to be hundreds or thousands of cells long for some problems, and right now, the Pokemon Turing machine only has 5. Fortunately, in one save file of Pokemon Scarlet or Violet, you can store up to 960 Pokemon, plus the 6 already on your team. After battling yourself on the second switch until you need to go past -2 or 2, forfeit the game, then on the Team 2 switch, apply the paralysis and damage to the Porygons that received it, as this will not carry over from the battle. Finally, swap out the 5 Porygons from the battle for the next 5 on the tape, and voila, the tape is now extendable. But how far can it be extended? The limit to this is just how many distinct Pokemon there are that can fill the role of a Porygon, so it will be a finite number, but as you will see, that number can be very, very large. First off, the Porygon are identified by the number that they are nicknamed. In Pokemon Scarlet and Violet, nicknames can have up to 12 characters. That means that the tape can go from -99,999,999,999 to 999,999,999,999 for a total baseline of 1,99,999,999,998 nicknames. Next, most Pokemon can be either shiny or not shiny, meaning they can have 2 different colors, like Smeargle 1 and Smeargle 2, so we can multiply this baseline by 2. The only Pokemon that can't fill the role of a cell are Pokemon that can't be paralyzed by glare. Any Pokemon whose ability makes it immune to paralysis can have its ability overridden by Smeargle 2 using Doodle, and of those Pokemon, only Kamala has an ability that prevents it from being paralyzed as its only possible ability anyway. Electric-type Pokemon are also immune to being paralyzed. However, by giving Smeargle 2 the move Magic Powder, their type could be changed. Unfortunately, Powder moves don't affect Grass-type Pokemon, so the Grass and Electric-type Pokemon, Ismene Voltorb, Ismene Electrode, and Rotom Mow, can't be hit with either Glare or Magic Powder. The only way to get around this is to have the Pokemon Terastallize, which is a once-per-battle mechanic that allows a Pokemon to change its type. But since it's only once per battle, for those Pokemon you would have to do them one cell at a time, which is slow, but possible. This leaves only one Pokemon, Goldengo. Goldengo is a Ghost Steel-type Pokemon that only has one possible ability, Good as Gold, which prevents it from being affected by status moves. Glare won't work on Goldengo because of its ability, and Doodle can't erase it. So to get around this, the third member of Team 1 will be a Hawlucha, holding a Leppa berry, with the ability Mold Breaker, and the moves Feather Dance and Thief. Hawlucha doesn't learn Recycle or Switcheroo to replace its Leppa berry, but Hawlucha does learn the move Thief, which steals the target's item. Thief does deal damage, and Smeargle 2 can periodically heal Smeargle 1 with Heal Pulse. Mold Breaker allows a Pokemon to ignore its target's ability, and by giving Smeargle 1 Skill Swap as its 4th move, Smeargle 1 can use Hawlucha's Mold Breaker ability to ignore Good as Gold and use Glare on Goldengo. Every Pokemon available in Scarlet and Violet should be able to learn a move that can consistently not interfere with the running of the machine, so all 733 Pokemon that can be used in Pokemon Scarlet and Violet can be used as cells. Next, Pokemon have 6 stats, each of which have 2 hidden values called IVs and EVs. What they do isn't important for this video, but these values have 31 to the power of 6 and around 6 to the power of 508 total possible combinations respectively. Each Pokemon can learn an estimated average of 60 different moves, and can know up to 4 of them at a time. One slot must be taken up by the non-interference move, but the other 3 can be any of the moves that the Pokemon can learn, minus duplicates. For the number of possible combinations of moves that will differentiate the Pokemon, we can multiply 59, the number of remaining moves after the non-interference move, by 58, by 57, then by 24, the number of ways these 4 moves can be arranged. So the final product is 59 times 58 times 57 times 24, or 4,681,296. Also, most Pokemon can be male or female, and can have an estimated average of around 2.5 different abilities. They can be from games in 9 languages, and can have any of 25 different natures. They can be any of 100 different levels, 255 different friendship levels, and can possess 615 different items, 2 to the power of 57 different combinations of marks, and 2 to the power of 115 different combinations of ribbons. This is already going to be a longer tape than anyone might ever need, but it can get even longer. The baseline for nicknames I said earlier was based on just counting, but if we expand the total number of possible nicknames, we can increase this number 10 quadrillion-fold. Because there are a total of 248 different characters on the keyboard for Pokémon Scarlet and Violet, and since each character name can use a maximum of 12 characters, we can replace the previous figure of 1,099,999,999,998 possible nicknames with 248 to the power of 12. Then we can add in another 248 to the power of 12 possible combinations, because Pokémon store the in-game name of the player who caught them, and players are named using the same 248 character keyboard. So finally, by multiplying 248 to the power of 12 times 2 times 733 times 31 to the power of 6 times 6 to the power of 508 times 4,681,296 times 2 times 2.5 times 9 times 25 times 100 times 255 times 615 times 2 to the power of 57 times 2 to the power of 115 times 248 to the power of 12, we can get the final answer of how many cells long the tape of the Pokemon Turing Machine can be. And that number is 4.9 times 10 to the power of 536. That is an absolutely insane number. It's larger than the number of stars in the observable universe to the power of 22. How many switches would you need to store this number of Pokemon? If you remember from earlier, one copy of Pokemon Scarlet or Violet can store up to 966 Pokemon. You can add 966 more if you buy the other game as well, and 6,000 more if you get Pokemon Home for free and buy the paid storage upgrade. There are 8 other Pokemon games that can be bought for the Switch to store additional Pokemon, even if they don't have all the same Pokemon as in Scarlet and Violet. Ultimately, I'll estimate that adds about 8,000 more Pokemon that can be stored. Finally, a Switch can have up to 8 users on it, each with a different save file, for a total of around 127,456 Pokemon per Switch. To be able to use the Pokemon Turing Machine to its full extent, it would take over 3.8 times 10 to the power of 531 switches. The base model Switch weighs about 400 grams, so if you gathered all these switches together, they would weigh over 1.5 times 10 to the power of 528 tons, which is around 18 sextillion quinquaginticentillion as much as all the ordinary matter in the observable universe. So that's it. The Pokemon Turing Machine, composed of 2 Smeargles, a Persian, a Hawlucha, and 490 sextillion septuaginticentillion other Pokemon. If you want to try out these teams for yourself, a text version can be imported into Pokemon Showdown is in the description. Thanks for watching, and happy holidays!